Hi guys. So we'll start with the next problem in the series, integer to English words. Okay. So convert a non-negative integer to its English to its English words representation. So given input is guaranteed to be less than. Just a second. Yeah. Okay. So given input is guaranteed to be less than. Okay. So we have been given integer to its okay, 123 is 123, 12,345. Okay, so I think with the example they have given some clarity. So we know that 2 to the power 31. So let me just give you int max value. So the int max value is this. So let us just paste this over here, and let us also copy this value, and let us just paste it so that we can confirm that both the sizes are equal. Yeah, both the size are equal. So we know that words which we use are what, and there is no and in between, right? Yeah, there is no and in between. So what we can do, first of all, we know the first word would be. So there are no. So yeah, we have been given this number, right? Yeah. So let me make a map, or maybe we can create a string array of tens, and we will bring 10 options over here, right? And then we will be having a string of ones. We will be having a 10 options over here. So what are the 10 options in this case? So it's like, let's say we have a number which is 12. So you just need to write 113, 113, 123, 134. So if the starting two words are 1, so if at the tens place we are having a 1, so I think there is a lot of things that we need to write. So let us first focus on the starting two digits to get the starting two digits correct. So first of all, let me write off all the ones, right? So it's like, do I need to capitalize or not? So the first letter is always capital. Yeah. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. let us make it till 20, right? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So we have in total 5, 10, 15, 18, 20. Yeah, I have not forgotten anyone. So we have written 20 choices. So now what I need to check is what are the first. So if number is less than 21, you can just simply return ones of number. Right. But if the number is not less than 21, if number is greater than, then what we need to do is we need to bring the first two digits of the numbers, right? So in ones place, so first of all, what is at the ones place? So this is at the ones place. What is at the tens place? So basically now minus equal to ones. So at the tens place we have num divided by 10 modulo 10. So if the number is 39, this will give me 3 and that should be the answer. If the number is 392, this will give me 39 and modulo 10 will give me 9. So this is at the tens place, right? So the number which we have, okay, so basically, yes, I wanted this two digits right now. So let us say we are framing our answer in this string. So if also let me write down the tens first. So for one, I won't write anything. Why? Because we already saw if the number is 113. So if the first two digits are less than 21, then we would use the above prefix. But if the first digit is, let's say, 20, then what we will do? So for one we will write 10, 20, 30, 40, 50, 60, 70, 80, 90, right? So this is for 0 to 9, 1 to 9. So if it is a 0, then we do not care actually. So let us say it is a, so if the number is 103, then the number should be 103. What should be the answer in case of a 0? 103. I think yes, we can skip that digit. It would be an empty string. In this case, 0 would be an empty string. Right. Now, if tens into 10 plus ones is less than 21, then what we will do? we will say answer plus equal to ones of, right? So I think we will brute force the entire solution in this way using if else conditions, because now there is a limit to which number will grow. So if this is not the case, then what will happen? So I think over here we should divide the number by 10. Yes. So once the tens digit is gone, we can again divide the number by 10. It is sure the number is greater than 21 or at least greater than or equal to 21. So if that is the case, that means the number has at least 2 digits. Therefore, we can do these operations, and after the second operation, it might happen that the number becomes 0. Why? Because if let's say number is 98, then we did divide by 10, so it came 9. Then we did divide by 10, so it will become 0. So now after this else, we need to check if the number is greater than 0, then only we will operate on the number, right? Else we won't operate. So now the second question is, what if this digit becomes greater than or equal to 21? In that case, what we will do? In that case, what we have to do is, first of all, we have to make answer plus equal to tens of, okay, because the arrays are also named with this, right? Yeah. So now tens of 10. So let us say the number, the tens, so the number, just so the last two digits is 6 and 3. So it should be like 6, it should spell like 63. So what we will do is, we will take 10, yeah, we will take this, and then we will push back a space, and then we will say, right? So now we are sure that after these two operations, we have successfully dealt with what are the first two digits. Now let us move to the hundreds part, right? So because in the worst case, we will only have billion, million, thousand, and hundreds, right? Yeah. So now, if like string of hundreds, now we need to take care of string of hundreds. So it should be like 100, 200, 300, and so on, right? So let us say if the number is now greater than 0. So what is the possibility? Let us scroll down for some test cases. So this should be 100. So now I take the next digit, so 123, then it should be 100. So if I take 1123, then it should be 1123 or 1123. So it should be 12,345. It should be 2,300. So it should be like 12,300. So now what we will do, it should be like, if the number is greater than 0, that means it has a digit for 100. So let us say HD denotes the digit, the hundreds digit. So now what we will do, answer plus equal to ones of HD, answer plus ones of HD plus space plus, let's say it should be like, just a second, 100. Yes, right. Yeah, this should be the answer. So now let us say if the number is still greater than 0, that means we have what? We have the thousands digit as well. So now in this case, we need to check the two places again, ones and tens, right? So now we need to check these two positions again. Why? Because we can have 12,000, right? We can have two digits. We can have a 12,000. So we will write it as, we will check these two digits. So now the number is, so answer would be, so yeah, suppose we have 63 over here, then we should have 63,000, right? So we need to check this out. What? Yeah, if this is less than 21, then we will have answer is equal to 1 plus 1000 plus answer. Else what we will have is answer would be equal to this 63. This would be like 63. It should be like 63,000 plus answer. Let us say the example is 3004. So in that case, first of all, we will have 4. Why? Because then in the hundreds we will have an empty string. So yes, what we need to check now, if HD is greater than 0 to, then only apply this. Otherwise there is no need. Over here as well. Okay, so yeah, that was the thing. If the number is 0, then we won't add it and add anything to it, right? So now the next question is, what if we have a number like 1, 2, 3, 4, 5 and 6, a number with digit 6. So this is a number with digit 7. It's like 1 million. So it's like 234,000. So we can have 3 digits as well. We can have over here 3 digits as well. So I need to check for the case of 3 digits as well. So let us say HD denotes the hundreds digit, right? So the number is now HD into 100 plus this. So if this number is less than 21, then obviously this is the answer. Else if this number is greater than 0, and if this number is less than, so is less than 100. And if this is the case, then else if PF is greater than 0, if the number is greater than 100, so it would be like 123, 133. In this case, what we will do, in this case, what we will do, we have this HD, right? So it should be like ones of HD plus, so it should be 100 and 13 or 14, 114. So we need to take cases, two cases in this as well. If ND is equal to 10 into 10 plus 1. So if ND is less than 21, is greater than 0, and ND is less than 21. If this is the case, then answer should be equal to ones of, so yeah, answer is equal to ones of HD for sure. Ones of HD plus 100. This is for sure. But if and is greater than 0 and it is less than 21, then answer should also be, no, 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 no. I need to add everything together. Plus ones of and plus what if any digit goes 0? What we will do then? Let us say 10th digit is 0. So we will do it 305,000, right? So next digit is hmm. Now the end is greater. Yeah. What else? Else we need to make more changes to our answer. 100 plus tens of 10 plus ones of 1. Now, yeah. Now this is correct. 345,623. Now the next is million, and in this case we have the digit 1, 2, 3, 4, 5, 6. So now we have covered cases wherein first 6 digit can be the possible answer. Now this is the size 7, and we have to cover to what size? So 3, 36, 39 and 10. We need to cover a size up to 10. So in the case of million, we can have 1 million, we can have 10 million, we can have 100 million, we can have 3000 million. And then in case of billion, we can have 234 million, we can have 235,000 million. With then we can have, yes, right. And in, we can have 1 billion, we can have just two. So in the billion, so once we complete this million, then we are good to go. Why? Because in case of billion, we have a maximum of 2 billion only. We cannot have number which is greater than 2 billion. So now the only case remaining is of the million, and in the million we have to take care of 1 digit, 2 digit, 3 digit, and 4 digit, right? So now over here, this is the case of considering the million. So now if the number is greater than 0, so now the end 1, this is the ones place of million, this is the tens place of, sorry, so this is the tens place of million, this is the hundreds place of million, and this is the thousands place of million. Now if, and let us create the number nm, which is nothing but th into 1000 plus hd into 100 plus 10 into 10 plus 1. So if nm is greater than 0 and nm is less than 21, if this is the case, then answer is quite simple, and that is answer is equal to ones of nm plus answer. Now the second thing is, what if nm is greater than 0, else if nm is greater than 0 and nm is less than 100. So we have two digits in the nm, so that is also easy. Why? Because we have tens of nm or tens of 10 in this case, ones of 1, right? This is also done. What if they have three digits, which means nm is greater than 0 and nm is less than. If they have three digits, then I need to check what are the first two digits. So int tmp is nothing but 10 into 10 plus 1. So if tmp is less than 21, then what I can say? I can say that answer is nothing but ones of hd plus 100 plus 100 and ones of tmp plus, yeah, right. But right, but if else if tmp is greater than 0 and that means the first two digits are, so answer is nothing but tens of sorry, ones of hd 100 plus tens of tens of 10 plus ones of 1 plus, so now yeah, so else if nm is greater than 0, if this is the case, so just make sure that even in above all the cases I have made the condition there. Right, because it is needed. Hmm. But like, yeah, why did I did this? Because suppose the number is just a single digit and it is 0, then we have to show it is a 0, right? Now what is the case? Now if lm is greater than 1000, that means it has we need to talk in terms of 1000. So if we need to talk in terms of 1000, so it should be like 3000, 13,000, 14,000, right? It is possible like that, right? 25, 234 million, 3,000 and 3,246 million, 13,456 million, 1,234,000,000. So it's like 1,000,000. So let me read it like this. So we have 234, 234,000,000, 234,567,891. So 891, 567,000 is done. 234 million, that is done. So it is not like 1,234 million. It is 234 million only. So there is no th in this. Right, so this is the case, and I think this is not required now. So with this, I think we are done with the millions case as well. So now we just need to take care if the number is if nm is greater, if the number is greater than 0, then just add one thing, that answer would be equal to ones of num plus 1 billion or 2 billion, whatever it is, plus answer, right? And then return the answer. Let us run this code and see what are the possible errors we have made so far. So there is a compilation error because we are pushing back, we cannot push back this. So, or instead of doing this, it more neatly and the principles which we have followed so far. Let us keep it in line with these principles. Let us see in big numbers what errors we have made. It was a very consuming question. What is the wrong answer? What is the answer? 12,345. So what is the output? 12,345. Okay, so 40 I have written wrong. It should be FORTY. That's great. I never expected that we would be wrong over here. Now, okay, there is no space. Okay, I think it is because of the excitement over here. How many test cases have passed? I am just curious to know the number of test cases. It should be less than 50% test case, I guess. Oh my god, I have passed 510 test cases. Okay, that's great. It should be 15, not 15. 18. Rest are right. Yes. So there are two mistakes which we did over here. Unexpected. Oh my god. Okay, oh shit, I have missed somewhere that it should be greater than 0. I missed that and is greater than 0 over here. Okay, 30, there are just two digits. So it is like the trivial case. We are over here. So we first found out the 0, then we found out the 3. Yes, 30. Okay, so I should not write a 0 over here. That is what you mean to say. But yeah, in that case I will be wrong, yeah. So just check the number. If number is equal to 0, then but I am worrying about the case wherein this one. So if I'm talking about 300, so let's say 360. 360 should be the answer. But what I will do is every time I will create an extra spacing because of this. Why? Because if I am saying that I am not writing anything over here, that means the incoming space, I need to modify my code. Why? Because if let's say the number is 360, then what is this will be doing? This will take 60 and this will take empty space. So my string should have been 60 ideally, but it would be 60 plus this extra space. So what I need to check just if one is equal to 0, the answer is 10 of 10. Else, yeah, right. Yeah, in this case, 1 is 0, then what you do is do not write this. You are here as well. In this, do not write this. Here as well. Here as well. Yep. I think now we are good to go. I have changed all the places wherein one can make an error. Okay, so I am again get why is 100. Yeah, this is the block for 100. So yeah, yeah, okay. It might happen that so before, yeah, it is possible that we have an extra space at the end. So yeah, but yeah, it is only possible once, not more than once. So if answer dot back, why? Because it might be possible we have an empty string and that's why we are okay. So I think it should be 100,000. Oops. So PF is greater than 0, but what if in the case of PF ND becomes 0? So we need to create another case where if ND becomes 0, then also answer should exist, because 100 is a valid answer. In the similar fashion, 1000 is a valid answer. 100,000 is a valid answer. So yeah, in that case answer will be equal to 1000, right? 100,000 will be the answer in this case. Then yeah, it might also be possible that the ones digit. Yeah, I think if there's all those cases are covered. In the similar way over here as well, we can have 100 million as the answer, right? So else if the number which we are computing it is non-zero, so else if nm is 0, then we should have answer is equal to what's the digit 100. So even this two we can have a no we cannot have a 1200 million, right? 1200. So yeah, we should have a single digit, right? So it should be like ones of h3 12. Yes, I think now I am exhausted with this question. Again, there is a runtime error, which is what test case is this? 536 have passed, 562. What should be the answer? 1, 2, 3, 4. So it should be 100, 1000. This should be 1000. This should be 10,000. This should be 100,000. This should be 1 million. No, no. So can we have 100,000? I'm wondering. This much 100,000, 100,000, 200,000. Yeah. So it should be like 10, 100, 1,000, 10,000, 100,000. What is million, man? 1 million is 100,000, right? No? Yeah. So this is 100, this is 1,000, this is 1,000, this is 1,000, this is 10,000, this is 100,000, this is 1 million. Okay, it comes next. So this is 100,000, 10,000, 100,000, 1 million, 10 million. Oh, 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 oh. Just the last, at the very last moment, what is happening? So the num is becoming, so it's 1 billion, right? But answer is empty. So if I process this as my input, just a second. Yeah. And secondly, if let me see out. I'm curious to know what is the value over here.